Okay, so last thing we're going to talk about on these notes is the key attributes of x-intercepts and y-intercepts. And so this is always going to be the same, no matter what kind of function you have. If you need an x-intercept, you are plugging in 0 for y. The x-intercept is an x value when y is 0. And then for the y-intercept, you are plugging in 0 for x and solving for the y. I always like to start with the y-intercept because that one's easier. And so for the y-intercept, x equals 0. So that gives us 0 plus 4 minus 3 using this rule, which simplifies to just square root of 4 minus 3. We know square root of 4 is 2, which equals -1. So you have to know your perfect squares. If you do not have your perfect squares memorized, you need to start memorizing them, because if you leave your answer like this when it can be simplified, that's going to be wrong. And so -1 is our y-intercept. And so for our y-intercept, we would type in 0, -1, or if they just ask for the value and not the whole point, you would just type in -1. I think your test and your exit ticket just ask for the value. And then for the x-intercept, that's the harder one. We have to actually solve an equation. And so let me get rid of this stuff. And so for the x-intercept, the y value is 0 this time. So that gives me 0 equals square root of x plus 4 minus 3. And so we have to solve for the x. So your first step in solving this radical equation is to isolate the radical. This minus 3 is outside the radical, so we are going to add 3 to both sides. And then to undo a square root, you have to square both sides. And so that gives me 9 if I square the 3. And then squaring cancels a radical. So I just have x plus 4 equals 9. Subtract 4 from both sides, and you get x equals 5. And so for an ordered pair, we would have 5, 0. But if Canvas just asks for the value, you'll just type 5. These are really nice values. Sometimes they're not. Sometimes they end up like that. And so that's why you're going to just be typing values most of the time. And then example 6. Let's start with the y-intercept. And so x equals 0. That gives me square root of negative, putting a 0 right there. 0 minus 3 plus 4. And so 0 minus 3 is just -3. And then negative becomes positive. That's good. If it was still negative, if you get a square root of a negative, stop. It does not exist because we can't take square roots of negative numbers. All right, so we have square root of 3 plus 4. This 3 is not a perfect square, so I cannot simplify this anymore. 3 is prime. That's as simple as this answer gets. And so for the y-intercept value on your exit ticket and test, you would type square root of 3 plus 4. So SQRT 3, close those parentheses, and then add the 4 outside the parentheses. Those parentheses are extremely important. I'm going to be kind of lazy about the ordered pairs for this unit. All right, for x-intercept, plug in 0 for the y. And so 0 equals square root negative x minus 3 plus 4. First thing we're going to do is subtract 4 from both sides. And then I'm going to stop right here, because just like we talked about on the front of the worksheet, I have a positive square root There is no way I can take a positive square root and get a negative number. Okay, and so this is where I stop and say D, N, E. And so on Canvas, the x-intercept does not exist. The y-intercept is square root of 3 plus 4. And so I want to go into that a little bit further down here on the bottom. Okay, you cannot plug in a negative number into a square root. That equals error. And then you can't have a positive square root equal to a negative number. And so when you see this square root equal to this negative number, that means it does not exist. Okay, and so the difference between having a square root equal to a negative, because a lot of people think, well, doesn't square root equal positive or negative? And that's true if you are solving an equation like x squared equals 9. If I introduce the radical to solve this equation, yes, x would equal the positive or negative square root of 9. But I added this radical to undo this square. Okay, here I did not add this radical. It was already there, and you're telling me it equals a negative number. That is not the same. So if you add a radical yourself to undo a square, that's when it equals positive and negative. If the radical is already there and it's positive, you don't get to add your own positive and negative in front of it. And we'll keep talking about this all year, but just, I get that question a lot, so I wanted to go ahead and address it. And so for the sake of example 6, the x-intercept does not exist. The y-intercept is square root of 3 plus 4. Last thing we're going to do is write an equation from the listed transformations. So it says, write the equation for g of x that is formed by reflecting it across the y-axis, horizontally compressing it by 1/2. I always need the fraction. Left 6, up 11. Okay, so they already put the g of x equals, so I'm not going to write that. But I need a square root, and it's reflected across the y-axis, so I know the negative's under the radical. And then compressing it by 1/2 horizontally means there's a 2 with that negative inside the radical. Good form, always. Left 3, up 11. If you do not have these parentheses, it is wrong. Otherwise, it's not moving left 3 unless that plus 3 is only happening to the x. So make sure you put your double parentheses. On Canvas, you would have to type the SQRT parenthesis, -2 parenthesis, x plus 3, close parentheses, then the plus 11. Everywhere you have a square root, you're going to be replacing it with SQRT parentheses. That's how you do your radical on Canvas.